Okay, this is a video reviewing the radicals quiz for anybody who wants to study for a retake. Now, the first section says to simplify fully. By simplify fully, underneath the square root, we're looking for perfect squares. I'll list out the perfect squares and the perfect cubes, just in case you want them. The perfect squares are 2 squared equals 4, 3 squared equals 9, 4 squared equals 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and I'm going to stop at 10 squared. Now these are all equal to 16, 25, 36, 49, 64, 81, and 100. Those are the perfect squares. Now there are also perfect cubes. The perfect cubes are as such. 2 cubed is equal to 8. 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is 125. And 6 cubed is 216. And we can stop there. I like 7 cubed, but it's unlikely to come in handy, so I'll throw it down there anyway. 343. Okay. Now I'm going to use those to break these down. The perfect square, because this is under a square root, we want to break it up into a perfect square from this red list. And oh wait, it actually already is one. 16 is 4 squared. So this is the easiest question. This becomes 4 squared if you're solving this in the method that I've showed you. And it can give up the square to come through, making the answer regular 4. I'm going to do the same concept for number 2. Look for a perfect square. Wait, 49 is a perfect square. So this can be rewritten as 7 squared. And I'm going to break up the x fourth into x squared and x squared. Now everything that has a square can come through. The balancer will let them on in. So the 7, the x, and the x. So my final answer is 7x squared, because it was 2 x's. And there's nothing left under the radical, so I don't actually have to write it at all. Number 3. I want to break these up into squares so that they can come out, because only 2's will work, not 7's or 5's. So x squared, x squared, x squared, x, that's 7 x's. And y squared, y squared, y, that's 5 y's, all underneath the square root. And everybody with a square is going to be allowed to come out. So 1, 2, 3 x's, 2 y's. So 3 x's and 2 y's are able to come to the outside. That's a bad arrow. There we go. And these y's are able to come out as well. And who's stuck? This x is stuck and this y is stuck. So underneath the radical, x and y. For 108, I look at my calculator, I say, I don't know which perfect square is going to go into 108, so let me check my calculator for a second. Is 108 divisible by 4? Is 108 divisible by, well, so it is, but I think there's a bigger one possibly, so let's see. Is it divisible by 9? Is it divisible by 16? Because the largest perfect square is going to make this easiest. If we can find the biggest possible one, it'll make the simplifying easier. 16, 5 times 5 is 25. Is 108 divisible by 36? 36 and 3. So that's going to be the biggest perfect square that goes in. So I'm going to break this 108 up into 36 and 3. The m squared, or rather the m to the 5th, gets broken into m squared, m. It's still all underneath a square root. 36 is equal to 6 squared. And now everything with a square can come out. So the 6, this m, and this m2 can all come to the outside. So who's on the outside? The 6, 2 m's, it's an m squared. And who's stuck? This 3 and this m. Question 5. This can be broken up into 49 times 2. The x to the 6th can get broken up into x squared, x squared, x squared. I'm going to put the square root back on and keep the 4 in front. 49 can be rewritten as 7 squared, and then I can take out anything that has a square. Remember, the square root is like a bouncer, and he's only going to let you in if you have a 2. That's your invitation. So hand over your 2, hand over your 2, hand over your 2, hand over your 2. So let's see, the 7 and 1, 2, 3 x's are all going to get to come out. And who's going to be stuck? Just the 2. So let's see now. I got a lot going on. So I had a 4 out front. I now also have a 7 out front. And I have 3 x's. So this is 4 times 7 is 28. X cubed. And under the radical still just the square root of 2. Question 6. I have the cube root of 135 p to the 5th. So in this case, I'm looking for cubes, and that's from this list. So I'm looking to see which one of these numbers will divide in, and then I can always change them back into those perfect cubes in order to simplify and take the stuff out. Now I know which numbers it's going to be. If you don't have this list or don't know how to make this list, maybe you want to write it down and study that way. I would say after you finish watching this video, you should try all the questions fresh without looking at notes. Try them on a blank sheet of loose leaf. Okay. So I'm going to pick up the pace a little bit. 135. We need to know what is that divisible by, and the answer is it is 27 times 5. P to the 5th is going to be broken into p cubed and p squared, because this bouncer wants 3's, and if you don't have a 3, you're not getting out. The 27 can be rewritten as 3 cubed. Now, who has the right invitation? This 3 does, and this p does. So 3 and p can come out, and 5 and p are p squared are stuck. So 3p came out, cube root of 5p squared. Question number 7. 128 is 64. I don't like that I'm using black. Right under the black question. All sort of blends together. 64 times negative 2. And the x to the 7th is going to become x to the 3rd, x to the 3rd, x. This is all underneath a cube root with a 2 in front. The 64 is equal to 4 cubed. That's why we chose it. And now let's see everything that gets to come out. The 4 can come out, the x can come out, this x can come out, and also just something that we said in class, we wrote in our notes, negative signs can come out from under cube roots as well. So let's see, 2 times 4 is 8. 2 x's came out, so x and x is x squared. A negative sign came out. And now let's see what's left. 2 and an x. And that would be my final answer for 7. Question 8. There are no perfect cubes that go into this. And this 2 is not big enough to get that x out. Right? The bouncer's not going to let him in. He does not have a 3. The only thing we can do is take out the negative sign, which would flip this into a positive. So my final answer should be 4 cube root of 147 x squared. 9. Adding and subtracting just means simplifying and then combining if they end up being like. So 245, this is under a square root, so I'm looking at the squares, the perfect squares. 245 is going to be equal to 49 times 5. That's underneath. Plus 5. And 80 can become 16 times 5. Now 49 is 7 squared. 16 is 4 squared. And anything with a square can come out. Remember that if we have two numbers in front, like here with the 5 and the 4, 5 times 4 is 20. So I got 20, and I've got a 5 stuck underneath. On the left, I've got a 7 on the outside, and a 5 stuck underneath. And let me bring down that plus sign. 7 rad 5 plus 20 rad 5 equals 27 rad 5. For number 10, it's still square roots, so I'm looking for perfect squares that divide in. So 32 is going to become 16 times 2, and the x squared is still there too, underneath the square root, with the 5 in front, minus x, and underneath the square root here, the 50 is going to become 25 times 2. 16 is 4 squared. 25 is 5 squared, and anything with a square gets to come out, so the 4 and the x. Same thing as before, 4 times 5 is 20, and the x came out as well. Who's stuck? Just the 2. On the right hand side, this 5 can give up its square and come out, so I get minus 5x. Negative x times 5, yeah, negative 5x. And the only thing stuck is the 2, square root of 2. Now if I have 20x rad 2 minus 5x rad 2, that is 15x rad 2. Question 11. These are dealing with cube roots now. So I'm looking at the list of cubes. The 54 is going to become 27 times 2. Underneath the cube root, with a 2 in front, plus sign, and underneath this cube root, 128 becomes 64 times 2. 27 is 3 cubed, 64 is 4 cubed, and they can each give up their exponent, your 3, for the cube root to let them through. 2 times 3 is 6. Who's stuck is just the 2. On the right side, the 4 came out, so plus 4. Only the 2 is stuck again. Cube root of 2. And 6 cube root of 2 plus 4 cube root of 2 is 10 cube root of 2. Question 12. 32 becomes 16 times 2, under that cube root again, with 10 in front, minus the cube root of negative 256, which, if I recall, is negative 120. What's the perfect cube that goes into this? Oh, duh. Okay. Yeah, even great mathematicians make mistakes sometimes. 32 is underneath a cube root, and I made the same mistake that a lot of you do, which is that I jumped right to the squares list. Now, the actual factoring of this is 8 times 4, because 8 can be rewritten as 2 cubed. On the right-hand side, this negative 256, I go to my cubes list, I try dividing some things in, and I end up finding that it could become 64 times negative 4. Now 64 can be rewritten, of course, as 4 cubed. This 2 is able to come out, because it had a cube. This 4 is able to come out, because it had a cube. And also this negative sign can, because that's just the rule. Negative signs can come out from underneath a cube root. So 2 and 10 is 20. cube root of 4. On the right-hand side, I've got minus 4 and a negative, so minus and minus. These two negative signs are going to make this positive. The 4 is in front. And a cube root of who's stuck, which is just a 4, just like the other side. So 20 plus 4 is going to be 24 cube root of 4s. Now let's multiply. Rad 7 times rad 3 is rad 21. There's no simplifying that. Square root of 15 times square root of 6 is equal to square root of 90, which can be rewritten as the square root of 9 times 10. 9 is 3 squared, and the 3 can give up its square to come to the outside. So my final answer here is 3 square root of 10. On number 15, 10 times 20 is 200. P squared times p cubed is p to the 5th because I add the exponents. This can be broken down now into 100 times 2. And let's break up the p to the 5th into some squares so some of them can come out. 100 is equal to 10 squared. And now let's see who comes through. The 10 can, the p can, and this p can as well. So 10 p and p is p squared, and who's stuck? The 2 and the p. For 16, I multiply these. 3 times no number here, so it's like an invisible 1. So it's going to be equal to 3 square root. 30 times 10 is 300. X times x cubed is x to the 4th. This 300 can be broken up into 100 times 3. X to the 4th can be x squared, x squared. The 100 can become 10 squared. I shouldn't forget about the 3 on the front. And now the 10, the x, and the x will all be able to cross out their exponents and come through to the front. So 3 and 10 is 30. And x came out, that's x squared. And who's stuck? Just the 3. For 17, 18 times 15 is going to be 180, 270. So it's going to be 270. P squared times p squared is p to the 4th, because we add the exponents. And out in front of the cube root was this 2 coefficient just hanging out, so I'll put him back. Now, cube roots that go into 270, because this is a cube root question, is going to be 27 times 10. The p to the 4th is going to get broken up into p to the 3rd with a p left over. All underneath the cube root still with the 2 in front. 27 is equal to 3 cubed. That's why we chose it, because it's one of the cubes. And now this 3 and this 3 can get crossed out and to allow the 3 and the p to come out. 3 times 2 is 6. This p was able to come out, and the 10 and the p are stuck. So stuck underneath the cube root is a 10p. Question 18. 4 times 5 is 20. 80 times 12 is going to be 960, so underneath the cube root is 960. X times x squared is x cubed. Y squared times y to the 5th is y to the 7th. Okay. Now I'm going to actually go to the calculator on this one because I'm not sure which perfect cube goes into this off the top of my head. So let's see. 960 Is it divisible by 8? Yes, it is. But let's see if there's anything bigger. Is it divisible by 27? Nope. Is it divisible by 64? 64 and 15. That's a great one, 64 and 15. So, I'm going to break this up into 64 times 15. The x cubed is perfect already. It has a 3. The y to the 7th is too big, so I'm going to break it down. Y to the 3rd, y to the 3rd, with a y left. The reason I chose 3s is because only 3s are allowed out from underneath a cube root. That bouncer's only going to let you through if you got a 3. 64 is equal to 4 cubed. And now I can look at who gets to come out. The 4 can come out, this x can, and both of these y's. So 4, the x, the y, and the y. And who's stuck is 15 and this y on the end. Alright, now I've got a 20 and a 4. That's going to be 80. 20 times 4 is 80. I've got 1x and I've got 2 y's. Both came out. So 2y is y squared. And then who's stuck underneath is 15 and y. I'll even do the bonus. This is subtraction, in case you were confused about that, subtraction. So the first thing I want to do is I want to find some factors. 320, for instance. I believe underneath a cube root, that is going to be equal to 64 times negative 5. X to the 4th, I'm going to break up as well. It's going to be x cubed x. Still all underneath the cube root with a negative 3x out front. On this right-hand side one, I've got minus 2 cube root. Now 625 is 125, which is a perfect cube, times negative 5. And this x to the 7th is far too big, so I'm going to break it up. X cubed, and x. That's still 7 x's. Now 64 is equal to 4 cubed. 125 is equal to 5 cubed. Anything with a cube can come out. So this 4 can come out. This negative sign can come out. And this x can come out. So let me clean this up before I move on. Negative and negative means that the front number is going to be positive. It's 2 negatives. 3 times 4 is 12. There was already an x out front, and I brought out another one, so this is x squared. Positive 12x squared. And who is stuck? The 5 is, and the x is. So I get the cube root of 5x. On the right-hand side, this 5 can come out. This x can, and so can this. And so can the negative. So once again, let's keep tally here. I've got a negative sign already here, and another one came out, making this plus. I've got 2 and 5, so that's going to be 2 times 5 is 10. 2 and 5 makes 10. And an x and an x. So x squared came out. Now who's stuck? This 5 is, and this x on the end. So cube root of 5x. Now 12x squared cube root of 5x plus 10x squared cube root of 5x. 10 and 12 is 22x squared cube root of 5x's. Okay, and that would be my final answer for the bonus. If you have any questions, you're going to have to see me in office hours because this was already a long enough video.